Hi everyone. Today I'm going to show you how to create a Kubernetes cluster from scratch using three virtual machines. I will also show you how to use Tmux. This can help you accelerate any interaction with multiple VMs. Then after the cluster is up and running, I will show you how to modify the Flannel configuration. As a bonus, I have omitted a detail during the cluster creation and I will show you how to troubleshoot that and implement the solution. Let's jump into it. This is the current configuration. I have created three virtual machines based on Ubuntu. First one will host the master role. This is where your control plan will be hosted. The two other VMs will be the workers that will host your pods and other Kubernetes components. In this configuration, I have used Hyper-V to create my virtual machines for two reasons. The first one is I got really bad performance with VirtualBox. Second is that Hyper-V is already included in Windows 10 for free. You can use whatever available to you, even cloud-based VM. Switching now to my SSH session on the master node. The only modification I did on all virtual machines is to update the etc hosts to create the mapping between my VM name and IP addresses. To quickly install all the required components on all the hosts, I will use Tmux. Tmux is a Linux terminal which will allow you to create different terminals, or what they call pans, connected to different hosts. But what is more interesting is that I can execute the same command on multiple terminals at the same time. Let's get started. First, I have to create some terminals. You do that by holding the prefix key, which is a control plus B, and the percentage sign. From every terminal, I will connect to a different host. I'm connected to worker 2 now. I will do the same for worker 1. You can jump between terminals by using the prefix control B and O. I will now enable the synchronization between all the pans by using this command. And here you see that I can execute the same command on multiple hosts. I'm going to use Kubernetes online documentation and show you step by step how to use it. This can help you, for example, if you are preparing for your CKA certification. Starting from the requirement, we have Ubuntu 18, which is okay. CPU, memory are okay. And here we are talking about disabling swap. Now Tmux in action. I will disable swap on the hosts. Next, we have to verify the bridge filter model is loaded. If not, we have to load the model. Then we have some parameters to allow AP tables to see bridge traffic. Here we have some a requirement for the firewall port that need to be opened, but for the lab environment, I'm just going to disable the firewall. Now I have to install the runtime. I will use Docker. Just to let you know, Docker will be deprecated for the futures. You have to use another runtime maybe. Here again we have some packages to install. Let's edit that repository. This is to install Docker packages. Let me maximize this. Some configuration element for the Docker daemon. And the remaining steps are necessary to enable and start the Docker daemon. I'm done with the runtime. Now I'm going to install Kubeadm. This will allow me to create my cluster, kubectl for running pods, and kubectl or kubectl for interaction with the cluster. Here are the requirements for Ubuntu. This part is done. On the next steps, I'm going to execute command on workers node one by one. So let's disable pan synchronization. Now I'm at the steps where I can create my cluster. There are some parameters that you can specify during the cluster bootstrapping, especially for the network, but I will keep the default here to show what kind of error you can expect if you miss that parameter. This is the command Kubeadm init. All seems to be good now. I have to configure kube control for my current user, and I can do that by using those commands. Let's test kube control to view the configuration. Okay, perfect. Now the final step is to make the worker join the master node, and the command to do that is at the bottom of the output. I will copy that and execute it from the other nodes. Okay, now we can see our hosts, but they are not ready yet. We need to install our CNI plugin. For this, I will keep it simple and use Flannel. This is the YAML file to create all the required objects for Flannel. Let me show you something on this file. This will be your backend network for pods, and I will show you how to change it post deployment. Okay, now I'm going to list what was deployed in our kube system namespace. you can see that Flannel pods are in crash loop status, and you can view the logs to see what's going on by using kubectl logs. And here is our error. So Flannel can't find the required pod-cidr. This is the parameter that we omitted during the cluster bootstrapping using Kubeadm. Let's first close all those pans. This is more readable now. I will show you what is the pod behavior if you have your CNI plugin in that status. I will create a pod. This YAML looks good to me. It only need a small modification. Oops, I forgot to remove the template section. I have now created a test pod, but it will get stuck at the container creating status. If you want to see more details, you can use the kubectl logs again. So before solving this problem, I will show you how to edit your Flannel configuration to specify a custom pod-cidr network. You can do this by editing the config map on the kube system namespace. Oops, my keyboard is getting crazy. I will change the network to 10.10.0.0.16. And now I have to specify the pod-cidr for my hosts. This will allow Flannel pods to restart with the correct network configuration. I'm going to recreate my test pod to see its behavior now. Now it's running, and the output is correct also. I will look now at Flannel pods outputs, and here you see that the pods are no longer in crashing status. And that's conclude our video on how to install a Kubernetes cluster. If you did find this video useful, please hit that like button and subscribe. Thanks for watching.